right, good evening, guys, and you're welcome to class 22 of DSA software course. And I do hope that we were able to deploy some of our applications yesterday. Yesterday, we touched on DevOps. We talked about CI/CD, why that is important in software development. And we also actually demoed how you can do that on Render and also on Netlify. So I believe you guys went back to actually play around with that, and I hope that you had some success trying to do that. All right, so in today's class we'll be looking at software testing, unit testing, and integration testing. I mean, there are many more testing type of testing out there, but I think we'll just try and limit our focus to unit testing and integration testing for now, because essentially that is what you will come across on your day-to-day as a software developer. All right, I'll do a quick recap on what we did last night in our last class 21, which is around DevOps and continuous integration, because this class is also more or less like a continuation from where we stopped yesterday. If you could remember, we mentioned that the CI process allows you to do some certain things, and if you could also remember that we said the CI process, which is called continuous integration, deals mostly on the code aspect of things, but all of that plays into the culture that DevOps engender, which is around regular deployment and kicking against the knowledge silos that we typically would have been, where you have software developers not working side by side IT operations. We defined what IT operation is, and we also talked about you as a software developer. So again, I hope that you guys were able to successfully deploy your app. Let me take a look at the chart to see if anyone was able to do that yesterday. Okay, nothing in affirmation to that. But again, the videos are there, the class slide is also there, and the repository that we played around with is also accessible. And again, I do advise that you lean in to use the LMS discussion tool. I got a question from there yesterday, and I hope that the response that I provided was able to unblock the person that asked the question. So again, try to use the LMS to ask your questions if you do get blocked at any point in time. All right, so let's dive right into today's class. Like I mentioned, today we'll be looking at software testing, the different types of testing you would typically encounter as a software developer, or working in a product team, or working for a software dev company, or if you're working alongside other people and building software that is in production, the type of test you typically carry out. So we'll just take a brief look at those type of tests, but we'll do a little bit of deep dive into unit testing and integration testing. And if the time permits us, hopefully we'll try and make time for it. We'll also try to show you some code to help solidify some of the lessons that we'll be learning today. All right. So, as this is a software development course, our focus again will be on unit testing and integration testing. And we take a look, like I mentioned, just take a very brief look at the different type of other kind of testing that you may also come across. So in our class yesterday, we mentioned that you will typically run tests as part of your continuous integration, right? So we also see how to set that up as part of a CI process using GitHub Actions. Okay, so once again, you're welcome to class 22, and our learning objectives for today includes understanding why testing is critical to software development, and then explore different types of testing: unit testing, integration, end-to-end, smoke test, load test, and how to apply the testing pyramid to structure test effectively. Also writing and running unit tests using Jest. I will describe what Jest is, and then performing integration testing with mocks and remix loaders and actions. Well, if you're able to touch on our React app, we'll do some integration testing for the React app. But the objective also include gaining exposure to the other different type of tests like smoke, exploratory, or load testing. Load testing is something that I find quite interesting, especially when your app begins to scale. You want to be able to test it under certain loads. And when we talk about loads, we are just talking about the different server load that can happen to where you have deployed your application. So as the users increases, the demand on your server also increases. Or if a particular part of the service you are offering is actually resource intensive, that will cause a bit of load on your server. So being able to test how your server responds under different kind of loads is actually very important for you to know as a software developer. And one of the other benefits, I mean, we'll still talk about it, but I just want to explain a little bit. One of the other benefits where you may want to really consider doing load testing for your software is that you begin to see where to make optimization for whatever software you're writing. So if you see that under heavy load, a part of the software doesn't perform as well as it should, that can be a good indicator that there is a need for a refactor. All right, the last objective here is that we will learn tools and strategies to incorporate testing in CI/CD. And like I mentioned, we'll be using GitHub Actions or GitHub Workflows. All right, so in order for us to achieve all of this, what we'll cover today will include why testing matters. We will talk about that, the different type of testing, the testing pyramid, writing unit tests, writing integration tests, or describing what integration test really is. End-to-end test, we will talk about that as well. Then what smoke test is, what load testing is, and exploratory testing. Okay, so let's dive right into it. But if you do have any question, feel free to drop it in the chat section, and at intervals, I will take a pause to look at whatever questions we have. And as much as I can answer, I will try to answer them. So in preparation for this class, and you might want to have your VS Code open, because we also have a workshop session where we'll try to dive a little bit into some coding, okay? All right. So testing, I mean, maybe we should define what testing is first of all. So testing is probably an activity that you carry out to ensure that something works as it is expected to. And testing doesn't just um, happen in software development alone. There are many other places where testing applies in manufacturing. There is a part of the manufacturing process where you check for quality. They call it quality assurance. So you can also think of testing as part of the quality assurance process that you would undergo as a software developer. So why it matters is that if you have testing in place, you'll be able to catch bugs early enough. And to catch bugs early enough reduces the cost of having an error in your production server or in your production environment. And then the other reason why it matters is that it ensures reliability, maintainability, refactoring, and also testing support scaling. So I will dive deep into each one of these and try to explain how testing plays a role in ensuring all of these potential benefits that comes along with testing. So when it comes to bugs, the cost of fixing a bug increases exponentially the later that bug is discovered. And then, I think it might also serve us well to talk about what a bug is. So a bug essentially is an error that occurred in your software, or an error that occurs in your software. So take for instance, you are meant to register a user, and in part of the registration process, a user is meant to provide a password. And typically a password, you want to have like a validation logic on it to ensure that the password is safe. Say for instance, you want to ensure that a password has a capital letter or has a special character, has a mix of numbers as well, and that the password is of a particular length. Say your password should not be less than 8 characters. Those are specifics that you want to put in your login flow. But let's not say that a typo happened in your validation logic, where when you are meant to provide at least one capital letter, you made a mistake and you said all passwords should be lowercase. But then, as part of the instruction that you gave on your UI, you said they must provide a capital letter. I mean, you can begin to see how much of a pain that would be, right? Where you are asking your user to do something, but your system is expecting something else. But if you have a test in place that is actually testing what you are asking for and what the system is expecting, you will see that even before you do a deployment, you will have caught that behavior. But without a test in place, a user will have encountered it, probably thousands of users, depending on how big your system is, right? So, and you're just really relying on users to tell you that, okay, this thing is not working, which means a couple of your users may have seen that behavior and may not be happy with it. And you may actually have lost users because of that. So these are one of the reasons why having a test in place is important. And when it comes to the economics of software or building a product, the people in marketing or in sales will tell you how costly it is to actually acquire one customer. So imagine how much you've spent on acquiring one customer and then having your system turn them away right? Just because you didn't implement testing. So such can be the cost of not having test in place, and that's why testing really matters. Another aspect is that you gain confidence to actually refactor, and you gain confidence to actually ship faster. Yesterday we were talking about the shipment cycle. When I say shipment cycle, the cycle at which software is updated and then delivered to the customers. So let's say you have a couple of features. Typically, what would happen before the era of DevOps and all is that shipment of new features will probably happen once in a week. But with the right tooling that we currently have in place now, you can actually ship a couple of times in a day, right? I mean, I've been in a software team before where we ship, I think, twice in a day, because the team is distributed across different time zones. So we try to ship twice in a day to catch the different time zones where people are distributed in. So more or less like at an interval of 8 hours, we try to ship. Other teams have different shipment or deployment strategies. Some, it doesn't really matter. As long as there is new code to ship, they just go ahead and deploy, right? But again, when you have testing in place, it can encourage faster deployment or frequent deployment, because you know that as part of your CI/CD process, the test is going to run, right? But without having a test, every deployment you're doing is more or less like a gamble, because you wouldn't know what's going to break next, right? And having tests in place also gives you the confidence to actually add more features, and knowing fully well that existing code won't break because of the new changes that you are making. So test ensures that you don't develop with fear. Fear-driven development is unsustainable. Testing lets you ship with a lot more confidence. So these are the two reasons why testing matters. The other few reasons that you may want to consider is fewer production incidents. Like I mentioned, you would probably catch bugs earlier if you actually do testing. And it doesn't really have to be just unit testing alone. You can also carry out integration testing. I mean, in the later part of this class, we will describe further what those are. But fewer production incidents occurs when you have testing in place. So it validates that deployment works end to end and verifies that the contract between services are actually maintained. So if you have a service that is expecting a type of data, you are ensuring that is that type of data that has been provided to it. You don't want to wait till you are in production before you start seeing things break, and then you start reacting, right? I remember one of the things that we said is the characteristics of the traditional IT operation method of deploying software is that they become reactive. So instead of being proactive in catching bugs, they will have deployed to a production server, and only then will they actually see things breaking. I mean, no matter how much you may have done QA, like manually go through the app, there are edge cases that you may actually not catch earlier on, and that only happens in a production environment. And also depending on the impact of environment that you have set up. Sometimes you may be working locally, and there are certain variables that are available to you locally and are not available in a production environment. And because of that, that may lead to your software breaking in a production environment. But once you have testing in place, you will encounter fewer and fewer production incidents. All right, so it enables continuous integration. I already talked about that. Automated tests are a prerequisite for CI/CD. I mean, it's one of the things that enables CI/CD as an approach to software deployment. Because if you take out testing, the speed that we gain with CI/CD can become a disadvantage, because if you're trying to move fast without putting a structure in place to ensure that whatever it is that you are deploying is thoroughly tested, then moving fast can actually be at the detriment of good quality software. All right, then one other thing that testing also helps with, I mean, as you advance in your career as a software developer, you will get to this point where you need to start architecting software right, and not just that, oh, the code works, it works. You now need to pay attention to software architecture, such as ensuring that your functions or classes are loosely coupled. They are not tightly coupled, whereby one is really heavily dependent on the other. Without one being there, the other can't function, right? You start thinking of singularity of responsibility. I think we talked about separation of concerns in one of our classes, or talk about modularity and so on and so forth. When you are approaching writing software with testing in mind, it actually forces you to ensure that your software is properly designed and properly architected. So we can consider this to be an added advantage from actually having tests in our code. All right, so having talked about the different type of software testing that we have, let's hone in a little bit on okay, maybe I should just show you a table that I have here, which sort of summarizes everything that I've just said. Okay. We were talking about different type of testing earlier. We mentioned unit testing, integration testing, right? But this gives a summary of it all. So having talked about why testing matters, let's jump right into the different type of testing that we have. And like I mentioned earlier, we'll focus on two major ones, which you will come across on a day-to-day basis as a software developer, which is unit testing and integration testing. So I will take off my video just so that you guys can see the slides properly. All right. So when it comes to unit testing, you know, your software is made up of modules, or you can call it functions, right? And functions are like the building blocks for your software. So when you are doing unit testing, you are testing these small building blocks in your software. It could be functions, it could be methods, it could be classes, but they act together as a unit, right? So for instance, you want to authenticate a user. A unit of function might be that you want to validate that the email provided is not already existing, right? So you might actually have a function for that, to check that the email that the user is providing is not currently existing in the database, right? And the reason why you want to carry out unit tests is to ensure that the core logic works as expected. Unit tests are very fast, they are very cheap, and they catch bugs early because, again, you are testing the very building block for your software. And when should you do unit testing? You do it during development phase. I wouldn't know if we'll be able to talk about the different type of software approach with testing in mind that you can have. There's such a thing called test-driven development, which a lot of people swear by, that it actually helps in building software. So for test-driven development, is such a way that you write tests first before you actually do implementation. So you write all the tests that need to pass before you actually start writing the code. And the reason for that is that you're writing to catch all possible cases, or to cater to all possible cases. Again, let's use our authentication function as a case study. So in authentication, there are a couple of things that you want to check for. One is you want to be sure that the email is actually correct, that the email being sent to the server is an actual email. So there are validation that you can run your email through to tell you that, okay, this is a correct email, and it's not a phone number, it's not just a random name, right? You want to ensure that it's an email. So in test-driven development, you can have one of your tests testing that the email provided is an actual email. And having done that, you also want to test that the email provided does not belong to someone else on the system. So you can have a test that is checking against that. And by the time you're done, you have several tests, right? And then you now begin to write code to ensure that the test actually passes. So that approach to writing or building software helps a lot, because all the potential bugs that can actually come up, you already cater to it before they happen, right? So that helps a lot. Another type of testing is integration testing. We say unit testing focuses on small isolated pieces of code, such as functions and all. But when it comes to integration testing, you are testing across multiple components. You're testing across multiple components. So you are not just testing one function. You are testing that this function and its interaction with some other function actually produces the right result you are looking for. Using our Quotes API project as an example, we have services. We defined a service layer. We defined a database or a repository layer, right? So in doing integration testing, you might want to test between the services and the repository layer, that what you are fetching from the database, how you are fetching from the database and what is happening in the service is actually producing the right result. Or another level could be end-to-end testing, where you are not just testing functions or classes or how data is being pulled from the database, where you're actually checking the responses that comes from an API endpoint. So for instance, you might want to check for your random quotes that it actually returns a quote. Or you might also want to check that the random quote returns no quotes if there are no quotes on the DB. So all of these are tests that you can carry out. And the reason for that is, imagine you only coded your system and made an assumption that there will always be quotes available in the database. Then whenever you hit that API endpoint, you are expecting to get a response. But what if it so happens that someone deleted all the data in the quotes table, and then you call the API endpoint? But because you have not written your code to cater for such a situation, there is high tendency that your code would break. Imagine your front end expecting an array or an object of quotes, but gets an empty string. If that is not already handled, it will cause your front end to actually break. So these are part of the things that we get as benefit from actually doing this different type of test. So we just talked about integration testing now, and also touched a little bit on end-to-end testing. But end-to-end testing actually simulates real user workflow through the entire system. So you're not just doing API testing and seeing that the API returns a response, but you are also looking at how the front end interacts with the back end. And the reason why you want to ensure that this is done is to ensure that everything works together in a production-like scenario. Again, you don't want to get to production to now start catching bugs. I think these are one of the things that actually stresses out software developers. I mean, imagine being woken up from sleep around 2 a.m. and being told that something that you just deployed now has caused the entire system to be pulled down, right? Or because there was no test in place or adequate test in place. I mean, you won't want to be in that situation where around 2 a.m. someone is calling you and you have to be on your computer and try to be resolving issues. I mean, some people do enjoy that. It makes them feel like a software developer, but I don't think that's healthy enough. I mean, it puts the business that you're working for, it puts them at risk, because if in the middle of the night, people that are not in your time zone are trying to access the software that you have built, but because of an error and you already are asleep and people are trying to reach you and they can't reach you, right? So all of those can impact the business you're working for. It can impact your work and the general experience that you will have as a developer. So that's why we encourage it, even though some people really doesn't find it fun to write tests, right? But it's highly encouraged. And also in a standard company, it is required because of the benefits it actually comes with. All right, so the other type of testing we have is smoke testing, load testing, and exploratory testing. So for smoke testing, this actually happens when you do a deploy. Say you deploy to a production environment, you are just clicking around to ensure that everything still works, because yes, you may have run your unit test, done an integration testing and all of that, but just to quickly check that nothing is broken. For example, you can go to the home page. If the home page works, then you know that, okay, your deployment was successful. Or you can call a specified route in your app that does health monitoring of the app. And if that loads fine, you know that everything is working fine. So I was explaining earlier that load testing is something that I actually find very interesting. So with load testing, you're measuring how the system performs under expected or peak load. So Facebook or YouTube, for instance, in a particular time of the day, they have their peak periods. So you may want to also learn about your app and the peak periods that your app has. So you may want to learn about your customers. When do they interact more with your app, right? Just so for you to figure out how to optimize your server, for instance, or how to ensure that there is more server power to tend to the number of users that you have. So that's that for load testing. So you may want to simulate 500 concurrent users sending messages to an API. And I think that's one thing that I also asked us to do during while we were connecting front end to back end, and when we deployed our quotes app. I wanted you guys to, at the same time, create quotes to see how much impact it has on the server. But unfortunately, we were not able to test that. I think we only had a handful of people who actually went ahead to create codes, maybe about 30. I was hoping that we could get like 500 concurrent active users trying to create codes at the same time. But you can have a sense of that if you consider your LMS and the times that quizzes are put up for you to take. I mean, given the number of people that are enrolled in the different courses under the SA, you can imagine that we could, at different point in time during a quiz, have like 500 concurrent users online at the same time and trying to access the quiz page. So if the server where the LMS is hosted is not adequate enough, you see that people are thrown out of the LMS just to accommodate for the load on the server, right? So you would want to test your server before you actually go to a live production and test for such scenarios where a lot of people are trying to access your service at the same time. So that's what you do with load testing. And for exploratory testing, you are manually testing by guided intuition or based on domain knowledge, just to be able to catch unexpected edge cases or if there are flaws in the UX, or if there were assumptions that an automated test may have missed. Okay, so this you typically do after releasing a feature, or maybe during QA, or before you actually deploy to production. I know all of these may fall under the purview of what QA testers will typically do, like doing load testing, smoke testing, doing an end-to-end testing, or doing regression testing, which is the last thing that we'll talk about. So for regression testing, you are actually testing old features to ensure that they still work after new changes were introduced into the system. So this prevents new code from breaking existing functionalities. And this you will typically want to do after every release or after a major refactor has happened. This part for QA engineers, they typically have this part automated. So it's not like they are clicking around. They already have automation set comparing how the system was before a new feature was introduced. And then lastly, we have contract testing, which verifies that two systems, probably your front end and the back end, or service A and service B, they agree on the data that they are exchanging. You know, I said earlier that you may want to test that when your API returns an empty response, that your front end is also prepared to receive such a response, not that the front end will break because no response was returned. All right. So those are the different types of testing that you may encounter in your software journey. But again, like I mentioned, the two that are most important to you is unit testing, and integration testing. And the table you are seeing right now gives a summary of everything that we just talked about. Once you have the class slide, you can go through it. But I can just run through it for the sake of those who may not have access to the file readily. So unit test, it tests single functions and catches logic bugs early. And you do this during development. For integration testing, you are testing between functions. So a function-to-function testing or module-to-module testing. Then for why it matters is it tests boundaries between two functions. And you do this typically after unit test. End-to-end testing tests the whole system, verifying that a real workflow still works. So if you have a login workflow, you're ensuring that the login works, that reset password works, that registration works. All of these are workflows, right? So doing an end-to-end test verifies all of this part of the workflows. And you do this typically before a major release, right? And then smoke test is just to check for the app health, that the app still loads and that the major pages on the app still works. So it's more or less like a fast way to check that everything is in order. So you do this typically after a deploy to production. Then for load testing is to check for performance of your server and also test for scalability and stability. And you do this before scale or before launch. I mean, once you figure out that more and more people are coming to your app, you may want to test for performance. Or if you already know beforehand, I mean, given the case of DSA, for instance, where thousands of students were expected to enroll to the program, so you already know that you need to cater for a lot of users at the same time, a lot of students in this case at the same time. So for that particular purpose, you would need to actually do load testing to ensure that when it matters, your system doesn't fail. I mean, you guys may have heard, for those in Nigeria, what happened during the recent UTME exam and the different issues that came up. I mean, those could have been caught earlier on if proper testing was done, if they did load testing, for instance, right? And many other tests they could have done. So all of that situation could have been averted. Then for exploratory, you go through the UI, check some logics out, and ensure that they actually match what was required. So why it matters, you do this to find unexpected issues. I mean, there are times that you run your automated test and some of these issues slip through. For instance, you have a UX that is jumping. I mean, when you start scrolling, it just jumps up and down. That one, you probably may not be able to write an automated test to catch that, but a human tester can go around and actually catch such issues. So you do this pre-release, and it's typically done manually. And then you have regression to test existing features, and then contracts to test for API boundary, just like we did with integration test or with integration test. So in all of this that we have described, you may want to begin to think that, why? And that would take us to the testing pyramid. But before we go into that, I will take a look at the chat section to see if there are any questions being asked. Yeah, someone is asking who QA engineers are. So just think of it like a typical product engineering process. Let's say you are manufacturing electronics or manufacturing phones, for instance. They ensure that the level of quality that is promised the customers is actually what they are giving out. So in your typical phone, they have things like IP ratings. Your phone could be rated IP59. I mean, I'm just giving a generic example to explain what QA engineering, when it comes to software testing, entails. So in the case of your phone, you have IP ratings, or you have ratings for the type of glass that is used on the front of the phone. So what a QA engineer would do is to ensure that what is promised is actually what is delivered. So during a QA process for a typical iPhone, for instance, they will submerge it into water for days. And if it still works, then they will tell you that, okay, it is IP59 or water resistant and dust resistant rated, right? And then they do all manner of tests like drop test and all of that. So same thing that a QA engineer would do, just to ensure that what is being deployed to the customers is of the quality that is required. All right. That answers the question, who are QA engineers? So a tester may fall under the title QA engineers, right? The question is, are the testers completely safe that they can guarantee 100% bug-free or flaw-free products? And do we carry out same type of testing for our product? Are these tests automated? Yes, some of the tests would be automated, like unit tests, for instance, that will run automatically. Like you raised, not all bugs will be caught, but you want to ensure that the critical aspect of your system is adequately covered. And that takes us to the topic on coverage. You know, you're writing tests for different units in the system, right? But you need a report on how much of the code in your code base you have covered. So sometimes your testing framework would come with code coverage as well. So it generates a report on how much in your code base you have unit tests written for, or you have integration tests written for instance. So we can't be 100% sure that everything we have is bug-free, but we want to be as sure as possible. And different companies have different policies around things like code coverage. Some would say they want 100% code coverage, right? But as it is with many other things, you should just try and find the right balance between having too much coverage or not. We'll get to talking about anti-patterns in testing and what the best practices are. And I think some of these issues will be addressed. Someone is asking, was there a situation where the system didn't have bugs, or the application where the bugs were fixed and never appeared? Are there always going to be bugs in any app built in any system? I mean, you can have an app that is bug-free, but really in real life, aiming to have a bug-free system is not the entire goal, because you are juggling between different resources. You are juggling for time. You want to release features on time and all. So if you can be 90% sure that, okay, the critical path in your system are without bugs, then you can live with that. Because again, given the fast-paced environment that we now work in nowadays, you want features to be released as early as possible. So if for the most part of it your system works, you can be okay with that. You don't want to aim for 100% perfect system, because for most of the users that will come to your system, they won't even utilize your system to the extent that you have written 100% code coverage for. Someone take YouTube for instance. When someone uses YouTube, it might just be that they go there to watch a particular channel, and that is it. They don't even bother to click like or comment, right? And there are many people like that they don't ever comment on YouTube videos, right? But there are a lot more features on YouTube than just that. You can explore your history. There's YouTube Shorts. I mean, there are many features. Again, I'm just trying to say that given that your users won't even touch every part of your system, to try and aim for a 100% bug-free system may not really be worth it, really, given that you are also trying to manage resources of developers, you are trying to manage expectations of feature releases and all. Another question is, how can you carry out load testing on an app that you just built and doesn't have much users? So there are different tools that you can use. They would mimic users. So when doing any of this testing, for the ones that are critical, you don't want to do them in a production environment anyway. Something like load testing, you don't want to do it in a production environment, because imagine you have 10,000 users and you want to load test your system, and you are bombarding it with requests from your load testing software, bombarding it with millions of requests. That means you are also depriving your 10,000 users the ability to use your system. So where you will typically do that testing will be maybe on a staging server. And a staging server is more or less like a replica of your production server, but not what your active users are using. You are just making what you have in your production environment, and that is what you do your load testing on. So it's not manually done. There are tools for it that can send thousands, 10,000s of requests at a time to your server, and with that you can test how your server performs. All right, let me see if there are any questions. Someone is saying they think unit tests are mostly lines of code, especially for APIs, and 100% no bugs depends on how you test. Well, I think I already spoke to that. Having 100% coverage most of the time may not be the goal, really, but having sufficient coverage to ensure that your system is at least free of certain bugs that can pull down the entire system. So let's jump right into the testing pyramid, and I think we will talk a little bit more on making this trade-off around what to test for. We talked about close to about 8 types of testing that we can perform, and like I was saying before I started taking your questions, that you may be tempted to want to do all of these tests, but it's not needed, really, because where you are testing it, take for instance load testing. If you want to perform a load test and you want to ensure that your server can serve like 1 million users at a time, or can handle 1 million requests per second, that means you actually have to provide for such a request. Someone was asking a question yesterday about the cost of hosting your apps on probably AWS or the likes. It can be as cheap as $15 a month, which is still some money. I mean, convert it to your local currency, it could be some decent amount of money, right? And it can go as high as $7,000 a month, $10,000 a month. I mean, there are people who have a bill of $1 million a month just to have their app in production. But all of these are dependent on the amount of traffic they are getting, right? I believe some of you may have seen one post by OpenAI that says whenever you say please, that costs them some amount of money to give a response to that, right? So all of these cost money, all of these cost resources, you don't have infinite amount of money to throw around. You are operating within the constraints of the resources that is available to you. So to ensure that your app at least covers all bases, right, you want to look at this testing pyramid. You want to have an end-to-end test in place, right? So testing pyramid is just a metaphor, right, for how automated tests should be distributed across your code base. So you want to do unit test, which is like the base of everything. At least those are cheap to run, and you can have your unit test run in a couple of seconds, so it's not costing you too much, right? Then in the middle of that is have integration test. So integration test could be that you are saying that your front end works with your back end and there are no issues. You can also have that automated, and then you can now do end-to-end test, right? Just to simulate how a user would interact with your app. So combining all of this together, you will see that you will have covered most of your bases, right? As against uh, making sure that, oh, end-to-end test is done, load testing is done, smoke test, integration test, unit test, exploratory test, then you do regression test. You don't need to do all of that all the time just to manage resource and all. So I further explained what the different slices of the pyramid would be in the next slide. So let's go to anti-patterns. And once we talk about anti-patterns and best practices, I think we will stop there and try to write some code. Okay, I think let's reserve this till after we've taken our attendance. So when we come back from taking our attendance, you we will talk about anti-patterns and best practices. Then we dive right into writing some codes. So it's an hour into the class now, and I think now you can take your attendance. All right, welcome back, guys. So we left off at talking about testing pyramids, and I said we will jump right into some anti-patterns and what some of the best practices are when you are doing testing, right? So when it comes to anti-patterns, you don't want to have too many end-to-end tests or too few unit and integration tests because that will be fragile and that will be slow, and that may lead to flaky test suits because normally end-to-end tests are actually slow. Like I said when we were talking about the testing pyramid, testing also costs money. So you want to have a good balance between unit test and integration test and then end-to-end test. Also, over mocking everything in unit test, it doesn't reflect real behavior. When we talk about mocking, and then that takes us back to what I mentioned about testing forcing you to actually architect your system properly or architect your code properly, like ensuring that there is singularity of responsibility and other things such as dependency injections, which allows you to be able to test your code as a unit and not having to draw in all dependencies on your functions, right? So when we have such dependencies and we're able to separate them, probably with dependency injection or the likes, what we tend to do is we mock those dependencies. And what we mean by mock is that you create like a replica of the dependency, but not the concrete implementation. It might just contain the return values and the likes. But you don't want to fall into the situation where everything that is in the system you have mocked away and you're not really showing how the function truly behaves, right? So that would be an anti-pattern because it won't reflect the real behavior of your functions or your classes or the service layer, whatever the case may be. So the best practice will be that you should favor unit test plus integration test for a fast feedback, right? Keep end-to-end test minimal. Just focus on the API path and the core flows, okay? And then another thing that you also need to do is use mocks and fakes smartly. So when a function is dependent on an external API, for instance, you don't want to call the API. Again, all of this is dependent on resource management. Imagine you have an API that is calling that you have an open AI API, which you know costs money, right? So you don't want to start writing tests that will be calling the API directly. You want to mock that API call so that you manage the amount of money you are spending, right? Also, when it comes to database, you don't want to flood your database with test data. So your test shouldn't really call or directly call your databases. You may want to mock that implementation or that dependency. You may want to mock that away. All right. So I haven't said all of that. We'll jump right into some code. We will use the project that we deployed yesterday, and we also try to use that to set up GitHub Actions and see the code and the unit test run on GitHub. So take time out to start your IDE for those of you that want to follow along. So for this class, we'll just try to do everything here and now. There is no Okay, so we'll do everything here and now, but I will also try to push an update to the repository and have that available to you guys. Okay, so I'll take a look at some questions. Okay, there are no questions. There are no questions. Okay, all right, so we dive right into our workshop section. So I have my my screen shared, and you should see it very soon. So I'll do a quick walkthrough of the tools that we'll need for writing tests. So for this case, we are writing tests for a Node.js app. So we are using that our quotes API project, the bare bones of it. The first implementation that is reading from file is what we are using. Like I mentioned yesterday, we did several updates to that project up to the point where we implemented authentication and we started reading quotes from the database. But just to make it a little bit easy for us, we just roll back to the first implementation that is reading from file. So the tool that we'll be using for testing on this project is Jest, and you can install Jest by doing npm install save dev Jest. But for our own particular situation, because we are using TypeScript, so you also need to alongside install the types and then install ts Jest. So I will show you the full command. But by the way, before we go to that, you can go through this documentation to get a lot more familiar with how to write tests. I think this getting started actually goes through the basics of setting up your project and writing your first test. But we'll do all of that in the demonstration. So the first thing we need to do, I've already opened the project in VS Code. So we open a terminal. For those of you that are still confused as to how a terminal works, it's not so difficult, all right? Let's see if I can have my terminal here. Okay, let's manage this as this. I'll increase the font so that you can see it better. So the code we want to run in this instance is npm install save dev. When we say save dev, we are saying that is not a primary, this package Jest is not a primary dependence, is not a primary package to the project, but we are using it for development purpose. And there are many other packages that are used for development purpose. So for such packages, you should specify that is a developmental package. And what that does is, in your production environment, it doesn't include it as part of the packages that are installed in your production environment. So save this, the Jest. We also are installing the types Jest and then ts Jest. So those are the things that we need. And then we wait for that to install. So while waiting for that to install, one thing that we need to do is create a folder where all our tests will be in. So we go to our source folder and put our test here, while those packages are still installing. So in source, you want to create a test folder. So I have a double underscore, which is like the typical way that you will write your test folder name. I mean, it has become more or less like a standard. Okay, so we have that, and we are writing test for this particular file, which is the file handler. So we have our file handler .test.ts. .ts. Okay. All right, so the installation is done now. Let's reduce this. We'll still come back to the terminal, right? But for now, let's reduce this. So one other thing that we want to do is also write a script for running the tests. So we write the script, and we want to specify what should happen when we do npm run test. So essentially we are saying this should run, right? And then we want to set up our jest. I mean, in other cases you might use a jest config, but for now let's just do the configuration right here in package.json. So we say jest, and then we want to use a preset. Again, like I mentioned, since we are doing this with TypeScript, we needed to install ts jest. So that's our preset, and then the test environment will be Node. Is Node. And then we want just to look for test in a particular folder. So test should match this. So we are saying look at all the folders and check for where the folder is named test __. Then look into all the subfolders in tests and all the files in tests that ends with .test.ts, which is the naming pattern we followed here. If you go back to here, so we created a folder test, and then we created a file .test.ts. So this should match this. So we are saying look at every folder, then find the folder that is named __test __. Then consider all the subfolders in that. Then consider the files that have this extension test.ts. So with this we should be able to have our test running, right? So let's run the script first and see what we get as response. So we do npm run test. So this npm run test is actually is running this particular line, right? So it's running now, and it should return that there are no tests found, because really we've not written anything inside our file handler test. So it says your test suite must contain at least one test. So right now we have no test running, and it says one failed, one total. All right, so let's try and write some couple of tests, right? Which should we start with? So in our file handler, we have a couple of functions. We have this get file path function, right? We have read codes. We have write codes. We have get codes by ID. We have add codes. We have update codes. We have delete codes. we have get random quote. So let's start with read quote. So in our read quote, we are sending a file path, and then we are trying to read data from the file, and then we pass the data and say that the return type should be an array of quotes. Quote is of this structure: ID, text, author, tags, right? And then if that doesn't happen, it should actually return an error that says error reading quote file, right? So that's what we have in our read quotes file, in our read quote function. But then we need to set up our tests, and there are different parts to a test. There are parts that can run before the test runs, and there are parts that should run after the test is completed. I mean, there are many more things that you need to consider when running a test. There's actually ascertain that a value is gotten. So we call those assertions. So you can describe a test and say, do this and do that. But at the end of it, draw the conclusion that what you are expecting to get is what you actually got. I mean, that describes it in a nutshell. So let's set up our test. We know that we want to test read quotes. So let's import read quotes from file handler. Then the next thing we want to do, we also need to import our type, because that's what we use to structure the response that read quotes is returning. So let's import quotes from types. And then for the jest setup, because we are reading from a file, let's import fs from fs. So import all as fs from fs. So this is needed in reading from file, right? So, I was talking about mocking earlier, that you don't need to have the concrete implementation. You can just mock how a function works or how a class works, whatever the case may be. So in this case now, we want to mock the fs module that we imported here. Again, this is just to show you how unit test works. I'm not going into the details of all that is required, and that's why I showed you that there's a resource that you can actually refer back to. I mean, testing is a whole set of skill in itself that a 2 hours class won't essentially do justice to. So you yourself can also go find out how to. I mean, I'm very sure there are a lot of resources online that can help you with that. Okay, so I haven't done this. Okay, we need to mock fs. So we do jest .mock, and we have access to jest because we've already installed it. So we are mocking fs, and then create a mocked fs equals fs as jest.mocked. Type of fs. Mocked is with a D, not C. All right, so we have our mocked fs. So in writing a test suite, you want to describe what test you're writing. So for this, we are writing a test for file handler. right? And these are the things that we want it to do. So first, let's mock some quotes. Const mock quotes equals an array of, is actually an array, not an object, equals an array of quotes. So we have the first quote with an ID of 1, then text. This is the structure of a typical quote as we have described it in the type, or as we have it described for this API. So test quotes 1, and we specify an author 1, and then we specify tags to be tag test and then quote 1. I mean, whatever, it really doesn't matter. Test, then quote 1. All right, that's that for that. Let's duplicate it and have a second mock quote, author 2, then we have a test quote 2 with an ID of 2 as well. Let me make this wrap. Okay, so that you can see the entire screen. Or let me widen this out. Okay. All right, I think this is good enough. Or let me close that. Okay, yeah, we are good now. So we have mocked quotes. The next thing that we'll do is we set up our before each. Like I said, you can set up how your test should behave. Here we can describe what should happen before each test runs. So we say before each, do the following. Just dot clear all mocks. So that will run before each. Now we want to describe a unit test. So we do describe again. First, we started with describing an entire test suite. So a test suite contains a series of other tests. So now we want to describe a unit test. Here we will test read quotes. Like I mentioned, is one of the functions we have in file handler. If we go to file handler, we have read quotes. So we are testing this, right? So for our read quotes, we would say it should read and parse quotes from file. So that's what our read quote should do. And how does it do that? First, we want to get the file mocked fs read file sync. So we want to do it asynchronously. We want to do it synchronously rather. The mock return value. This mock return value should be JSON. The stringify mocked quotes. Mocked quotes. All right. So now we start doing our assertions. We'd say const result should be read quotes. So expect results to equal mock quotes. And also expect that the read file sync should have been called on fs dot read file sync to have been called. Right, so we can do this and also still describe another behavior for read quote. You can say it should return an empty array when file read fails. So, like I described, that we are not just doing the API path, we should also cater for when the function actually returns maybe something empty, right? So we can actually write test for that as well. You can see that the way we are writing feels like the normal way you would talk, like it should read and pass code from file and so on and so forth. So that's a style of coding that is closely related to behavior-driven development, which test-driven development also learned from. So you can take a look at behavior-driven development and also check out test-driven development, and you see some of these things that we are writing there as well. So like I mentioned, it's an art in itself. So I don't expect you to understand it at a go or learn everything about it in one day, but you will get a hang of it as time goes on. So it should return empty array when file read fails. So how does that happen? We're still using mocked fs dot read file sync dot mock implementation throw new error. So when an error occurs in read file, we are essentially assuming that it could not read the file and it could not get quotes, right? So when that happens and we get a file not found, we are saying that results from read quotes should be empty, right? So expect results to equal an empty array is what we are essentially saying. So I haven't written this. Let's run the test and see what result we actually get. So we do that with npm run test, and while that is running, I will wait to see if there are any questions, right? Okay, so we have one test suite running and 2 tests passed. All right. Okay, no questions for now, so we'll keep on going. Write a couple of more tests. So I think we have about 20 minutes more. So I'll write a couple of more tests to just get us familiar with the whole idea of testing. Then before we end the class, we'll try and see how we can have our tests run automatically on GitHub with GitHub Actions. All right, so I'll reduce this and continue with the test. So we just described the one for read codes. Let's describe another test for write codes. So we want it to write code to file, right? So we say it should write quotes to file. And what are we expecting to happen in that? Still using mocked fs dot write file sync, mock that implementation, and in the mocked implementation, this is what should happen. Actually do nothing. Then const results. Again, we are dealing with mocks, right? So we don't need a concrete implementation, right? So we say the result should be write quotes mock quotes. Here we need to import write quotes. Remember earlier what we only imported was read quotes, but since we're writing for writing tests for write quotes, now we also have to have that imported. And our expectation is that we expect result to equal mocked quote. And also expect that the file stream read file sync was also called. To have been called. All right, so I think, yeah, I think that's sufficient for an expectation. And we can also continue to, okay, we want our result here to be true, not, because in our write codes we are not returning mock codes. We want it to be true. Let's take a look at file and read codes, write codes. So it actually returns true, not mock code. So we want the result to be true in this case. And we want mocked file sync, not read file. We are writing, so write file sync to have been called, and to have been called with, we expect any string. So what it has been called with should be a string. That's what we are saying essentially. And JSON stringified mock quotes null to, and the type should be UTF-8. I mean, if you go back to the concrete implementation, you'll see what we are talking about. So file path, then the data, then this, which is essentially what we are saying. We are saying expect write file sync, which is the same as this. Expect write file sync to have been called with the following argument. So a file path, which is a string, and then the quotes, which is this, a stringified quote, and then the type. So if we run this, if we run this and this being true, we will get a pass. So two things that we are expecting here is that the result should be true, and we also are expecting that for this result to have been true, this should have happened too. So result should be true, and then expect that write file function was actually called with the following parameters. So let's run the test again. npm run test. All right, so we have 3 passing tests now. So you can continue building and building on that until you have covered all that you need to cover. So I was talking about code coverage earlier. I think maybe we should do that also. But before we do that, I think let's try and meet our objective first of ensuring that we have a GitHub action set for this. So we wrote all of this on test API deploy, right? So the first thing that we need to do is you go to, let me confirm that. Git status, git branch, main, okay. Git remote v. Okay, all right, we are on the same repository. So for this now, what we can do is go to actions, and in our actions we will be presented different workflows. So you have suggested repository, you have for deployment, you have for security, you have for continuous integration. So the one we are interested in is continuous integration. So under continuous integration, what we are interested in is Node.js. So we click on that, and then it presents us with some options. So it has a pre-written code here, and this you can actually write it by hand in your GitHub, in your repository. Well, this is providing us with a template that we can actually work with. So it's saying that when a push happens to main, you should run this. When a pull request is opened against the main branch, you should run this. And it's describing the computer that is being used for this. So it runs on Ubuntu and uses a Node version 18, 20, or 22. And the steps, you do a checkout first, and then use Node, and then set up actions, and so on and so forth. But what we are interested in is this portion. You remember we have a script in our code that we actually use to run the test. So that will be useful in our deployment. All right. You know what? Let's actually do this. Copy this and put in our GitHub folder. So it expects to see this in GitHub/workflows in Node.js YAML. Okay, so we just copy all of this. Copy, put it in your GitHub folder, which you should be able to see. Oh, I see. Anyway, let's do it from here without having to tamper with things on the local repo. So what we want here is to commit changes, right? So create a pull request. You can also do it on main, but I don't want to do it on main because we actually already have some code in main. So you see that some things are running now, which you typically not have before. So it's running all of this, but it will fail because we actually do not have any test written, right? So regardless, let's just go ahead and merge. So on this side, I'll create a branch first. Git checkout. Test CI. Git checkout. Test CI. Okay, so we have a new branch now. Let's create a commit. Add test. All right, commit that. Then we'll do a git pull origin main so that we have all that we currently have in our main branch in this branch as well. All right, and let's do that command again, git pull origin main. All right, so we have pulled this in. You know, earlier I was saying that we can write it manually, but we decided to do it from GitHub. So what we could have done manually is still the same that we ended up right here, right? All right. We don't need this for now. You can try to do that at your own end, installing GitHub Actions, just so that it can provide some utility for running GitHub Actions. But let's proceed with what we have started here. So what we want to do is we want to push our commit. So we do git push git push setup stream or git push u origin test CI, and we have that pushed now. But what we'll do is create a pull request. So create a pull request against main, and we do that by creating pull request. So if everything works fine, we should see our CI working here. So CI is running here, and if everything indeed works fine, we should see that our test runs. If anything breaks at this point, you would need to go to your YAML node.js.yaml file to actually look at what could have happened. But everything is green now, which means everything actually worked. Let's click into it to see what happened. So for each of the different node version, we ran those tests. So run npm CI is one of the commands we specified in the node.js.yaml file. We say run npm.ci, run build if present, but we don't. Do we have a build? Let me see from our packet.json. Okay, we do have a build. So that will have run, and then lastly it runs a test. So let's check the outcome of each. So here, all of this run, and then in our build, it says it should do a build if present. So it actually ran our build command, which is .tsc, and then the part that we are really interested in is the test. So we see here that the test passed. This is what we are most interested in. It says 3 tests, 3 passed, 3 total, right? So for this, we will say our CI ran successfully. For this error that is happening here, I think is a wrong error handling happening somewhere, but really it doesn't matter as long as the test that we want to run actually ran. That's what we are most interested in. And here it actually ran. Now let me increase the font size here so that you guys can see what I'm talking about. Okay. All right, so what we are interested in is actually this portion here, which was the same thing that we saw when we ran this locally. Let me scroll up to that point. So when we ran our test locally, this was what we got, right? And the same thing we have here. So the other part that I also want us to probably touch on is what I call code coverage, right? You know, I was saying earlier that, some question came up that can we have a 100% bug-free software? And I mentioned that going for 100% is not really the issue, but actually ensuring that you have a good code coverage, like most part of what you have running in your code base is actually touched. So you can set up a code coverage for your code, and all of that is just some piece of configuration. So let me draw this down, and we go to our package.json and have that set up. So the first thing that we want to do is have a test coverage script, and to do a coverage, we just do just coverage, and that's all we need. And then further options that we can provide will be under jest. Further configuration that we can provide will be under jest. So we say collect coverage from I'll specify the files that I should look at. So we are saying look at source folder, every folder under source that ends with a .ts. We can also specify what it should not look at. So we say don't look at source folder that contains, and folders under source folders that contains file that ends with .d.ts. In our case, we don't have such, but let's just include it. You can also say you should not look at types because you really don't test types. So source types .ts. So it will look at all of those when drawing a code coverage. Then we can also say that the code coverage result should be stored in a particular folder. So coverage directory. It should be stored in a folder called coverage. And then lastly, coverage reporters. So these reporters will be like the type of report that should be generated. You can generate text. You can do a line covered, which is called LCOV, or you can generate an HTML page for it. So we go ahead and specify those three coverage reporters. So we have text. Maybe we should just let's specify the three: LCOV, and then HTML, and then another configuration is the threshold. So coverage threshold. So here you can say you want your code to be 100% all the time. But again, like I mentioned, in most realistic situations, you actually don't go for 100%. You can say in your team, what you're looking for is 80%, and that you are fine with 80%. So branches will be like if statement and all of those. So cover 80% of those. And then let's say functions, lines, statements. So we have specified that now. So now we can now go ahead to run our coverage, and we do that by running this script here, which is test coverage npm run test coverage, and yep, we should be generating our coverage now. Let's close all of this so that we see when our coverage is actually generated. Yeah, the code coverage has been generated, and we have a file in that regard. So we can look at this HTML folder to see it at work, and you see it generated a report. So it's showing all the lines that were not touched so far, and those are the ones that we see in red. And if you remember quite all right, we only wrote test for read quotes and write quotes. We wrote test that covers every portion of read quotes, right? But we only wrote test that covered the API path that returned true, but we never covered the part that returned the false, and that's why it's marked as red. So that's that for code coverage. And with that, we come to the end of this class. I think we are right on the hour mark, and I do hope that you guys gained quite few knowledge from what we did in this particular class. So we'll see you in the next class, and do have a good day and enjoy the rest of your night.